Calc. We're in 2.6 here with rational functions. All right. Let f of x equal n of x divided by d of x, appropriately named for numerator and denominator, right. And both the numerator and the denominator have to be polynomial functions. Okay, we've studied polynomial functions, so you got a pretty good idea what they are already and how to manipulate them and find their zeros and all that kind of good stuff. Okay, there's 4 things that I want to discuss with you today, and I'm just going to spoon feed that information to you, and then we'll cut the video after an example, and then I'll entertain any questions that you happen to have, okay? All right, the very first thing I want to talk about with rational functions is the possibility of having a vertical asymptote. Okay? So the very first thing is vertical asymptotes. And I'm going to put parentheses around that S. Why am I putting parentheses around there?
One or more.
Yeah, I could have one, or I could have more than one, or maybe I don't even have any. But I basically, when you see that, you don't know whether what you're dealing with is plural or not plural. Okay? So vertical asymptotes, we're going to ask ourselves a question and answer it, okay? I want this all in your notes so that when you have these questions for yourself, you can go right back and you can see these questions and you can have them answered for you right in your notes. How do I find the vertical asymptote? How do I find the vertical asymptotes? And the answer to that, simply enough, is set the denominator equal to 0. Solve for x. I don't need a comma here. I'm going to say and check to make sure the value, and I'll even say the x value with an s, because you might have more than one. Check to make sure the x values don't make, I'll say do not, to emphasize the word not, do not make the numerator equal 0, 2. So how do I find a vertical asymptote? I set the numerator equal to 0, solve for x, and check to make sure the x values do not make the numerator equal to 0, 2. And that's it. So no matter what my polynomial functions are, I'm going to grab this denominator, I'm going to set it equal to 0, I'm going to solve for x using the rules that we already know from polynomial functions, and I'm not even going to get tricky with you. I might give you a quadratic, I might give you a cubic. They're not going to get tricky with you at all. Set that thing equal to 0, solve for your x values, and at some point before you give final answers, make sure that you check to make sure that the x values you give me for vertical asymptotes do not make the numerator equal to 0, 2. A vertical asymptote is a location where your function equals 0 on the denominator but not on the numerator. If an x value makes both the numerator and denominator equal to 0, then you're not dealing with a vertical asymptote, you're dealing with something else. Okay? And we're going to play with that in 2.7, not 2.6. So for right now, don't worry about it. Just make sure that when you respond to me with x values that make your numerator equal to 0 but not the denominator, that I said it backwards, didn't I? Make sure that when you respond to me with x values that make your denominator equal to 0 but not your numerator, okay, that you've double checked everything and you're not giving me something that makes both numerator and denominator equal to 0 at the same time. Right. That's it for vertical asymptotes. So the next thing I want to do with you are the x-intercept. Okay, so I'm just going to write, again, possible, more than one. Have you ever seen a function cross the x-axis more than once?
Mm-hmm.
Sure, polynomial functions go crazy over that x-axis, right? Tons of different roots. Okay. Alright. Anybody have an idea how you find x-intercepts for any function? This isn't any different. We're just gonna do it again for rational functions.
Set equal to 0.
Say it again.
Set equal to 0.
Set it equal to 0. Set, what's it?
Y.
Okay. Set y equal to 0. Okay. So let's just think about this for a quick minute, not too long. Here's my x-axis. Here's my y-axis. Any point on the x-axis, I don't care where you are, any point on the x-axis has something in common with every other point on the x-axis. And what is that?
The y is 0.
The y is 0. So this would be like the point 1, 0. This might be 2, 0. This might be 3, 0. This might be negative 1, 0. Negative 2, 0, and so on, right? Every single one of these points on the x-axis, and you already know this, has a y value of 0. So if you know that an x-intercept has a y value of 0, you use that to your advantage to put that 0 in for y in order to solve for your function. So x-intercepts, how do I find the x-intercepts? And the answer is what?
Set y equal to 0.
Set y equal to 0, say let y equal 0. Now, what does that mean for your function? I mean, if you have f of x equal some polynomial over some polynomial, and we have a rational function, rational meaning fractional, when is it true that a fraction is equal to 0? How do you make a fraction equal 0? What has to be going on? You're right the first time. If the numerator equals 0, but not the denominator. If the numerator of any fraction equals 0, but the denominator does not equal 0, then the value of that fraction is 0. Are you with me? So I'm going to erase this in just a second, but for the sake of writing it down for you guys right now, f of x equals the numerator divided by the denominator. The only way that f of x, which is my y, can become a 0 when you know you have a fraction is if you have a 0 on the numerator and a non-zero number on the denominator. Do you guys understand that 0 over 0 is not defined? If you try to punch that in a calculator, 0 divided by 0, you're going to have an error because there's no such thing as dividing by 0, which is exactly why you're not allowed to divide by 0, which is why we have vertical asymptotes, because these are values where the function doesn't exist. So here, when I want to take this rational function and set my y value equal to 0, I can actually create a little bit of a shortcut if I want. I can simply take my numerator, set it equal to 0, get those answers, and then test those answers or that answer in the denominator to make sure it's not 0. So it's going to kind of sound like this. Okay? So I'm going to erase this little bit that I have here. I'm going to write a few more words out. How do I find the x-intercepts? What can I say? Set
Let y equals 0.
true. We had that on the board a second ago. Let y equal 0. But when y is equal to 0, that'll give me a fractional value equal to 0. And the only way a fractional value can equal 0 is if the numerator equals 0, but not the
denominator.
So I could set the numerator equal to 0. Set the numerator equal to 0. What's my next word?
Not the denominator to 0.
Follow. Set the numerator equal to 0.
Set the denominator not.
Solve. Solve for x. And
Check to make sure.
and check, help me again, and check to make sure what? I do want the y value to equal 0. That's how I start. And check to make sure
To x
Denominator.
the x values, more than one maybe, what? Do what? the denominator
0.
equal 0, 2. Okay. Super important. Vertical asymptotes, you try and find where the denominator equals 0 but not the numerator. X-intercepts, you try and find where the numerator equals 0 but not the denominator. And we do that because vertical asymptotes are undefined values and fractions are undefined when your denominator equals 0. That's why we're setting that denominator equal to 0 to figure out where the whole entire rational function is undefined. However, when I want an x-intercept, I want that y-coordinate to equal 0. And the only way the y-coordinate can equal 0 with a rational function is if the top or the numerator is a 0, but the bottom is not a 0. Got me? So I know it sounds like you're kind of doing the same thing. So you might want to think, oh, this one's vertical asymptote and that's horizontal asymptote. Don't think that. Don't think that at all. You might think these are x-intercepts, so these over here have to be y-intercepts. Don't think that at all. Okay, if you're solving for x, you're either finding your vertical asymptotes or you're finding your x-intercepts. These are the two hardest things to do. Okay. Any questions or comments? I'll get to an example in a few minutes. But x-intercepts. Okay. What are you gonna do next? We have vertical asymptotes, x-intercepts. You can tell we got two more things to do though.
Horizontal asymptote.
Horizontal asymptotes I'm gonna save for last.
Y-intercept.
So we're gonna do y-intercept. How do you think we have to find a y-intercept?
Set the denominator.
Let x equal
Yeah, we just do a whole denominator equals 0. Yeah? How? Okay, so I'm gonna write y-intercept, and I'm gonna make a line underneath it, and I'm gonna say, how do I find the y-intercept? Now I have to be careful here and not put an S on the end of that. Why?
There's only one y-intercept.
There's only one, if there's one at all, but there certainly cannot be
2.
2 or more. How come?
It wouldn't be a function.
The original function would not be a function. Okay. And do you understand why? You're nodding yes, that you understand why, but do you? It wouldn't pass, yeah, the function wouldn't pass the vertical line test if I have 2 y-intercepts.
And like the
Right.
x's can't go to the y's multiple times.
Yes, a single x cannot go to the y's multiple times. I got you. Okay. So let's just, like I drew the y-axis earlier and labeled a bunch, I drew the x-axis and labeled a bunch of points. Let's label a few points on the y-axis. What's true about any point on the y-axis?
x equals 0.
This is when x equals 0. So if I just put a couple of points down here, like what would that be?
0,
0, 3. What about this one?
3. 0, -2.
0, -2. What about this other
0,
one?
-4.
0, -4. So what's true about any point on the y-axis? The x value is 0. So we're going to use that to our advantage, use that knowledge to our advantage, because when we want to find our y-intercept, we're going to know that the x value has to equal 0. So how do you think I'm going to find my y-intercept? Let x equal 0. And what? Let x equal 0 and solve for y. Let x equal 0 and solve for y. And I can think of something I didn't do, and the notes are gone here on the board, but I can bring it back up in just a second. Okay. When you solve for your y-intercept, you're letting x equals 0, so therefore x equals 0 is the input to your function. And each input is only allowed to have
One output.
one output. Okay, not 2, not 3, otherwise we won't have a function, because a function is a relationship where every input is paired with exactly one output. So we can't have 2. The other thing too is, like, if you drew this vertical line, which would be your y-axis, and you had 2 points on it, wouldn't it cross twice? So your vertical line is really an x value. So I didn't tell you this earlier when I did the x-axis, but I want to make sure we do this now. The y-axis actually has an equation, and the equation of the y-axis is x equals 0. What do you suppose the equation of the x-axis is?
Y
Y equals 0. So the x-axis is what kind of a line? Horizontal, like looking at the horizon, right? This is a horizontal line. So horizontal lines always have y equals with some number. So y equals 1 would be a horizontal line just up 1. Y equals 2, y equals 3, y equals 4, y equals -1, y equals -2, y equals -3. Okay? This is x equals 0. X equals are vertical lines. When you're graphing calculator, do you have an x equals button? You got y equals though, right? You can go graph anything under y equals, but you can't graph anything under x equals because x equals is not a function. So you get x equals 0, x equals 1, x equals 2, x equals 3 are vertical lines. X equals -1, -2, -3, which is why we have vertical asymptotes at our x values. Okay. Something I did not do with you before, and I want to make sure to do it right now. Your y-intercept, when you give me an answer for a y-intercept, it has to be an xy coordinate point, and it has to be 0, comma, some number. The first coordinate must be 0. Clear? Go back to where you had your notes for x-intercept, where I had it underlined. And if you give me an answer for an x-intercept, it has to be an xy coordinate point with some number first and then a 0 for that, for the y-coordinate. And what's the other thing we did? What's the first thing we had on the board? Vertical asymptotes. So if I had vertical asymptotes, and I had that written with an S in parentheses and it was underlined, how are we going to give those answers? Read what you have for vertical asymptotes. How do I find my vertical asymptote? Set the denominator equal to 0, solve for x, and make sure that those x values don't make that numerator equal to 0 also, right? So what do we have? We have vertical asymptotes. So that should be given as some kind of x equals some number. Just like this, y-axis is x equals 0. Any vertical, this is a vertical line. And this is a point. And this is a point. Okay? Alright, that's pretty simple. That's probably the easiest thing there is to do in the whole entire test. Y-intercept. I don't know, the next thing is kind of simple too. What's the last thing we need to do? Horizontal asymptotes. Are we okay if I erase?
Yeah.
Sure. This is my favorite piece. Horizontal asymptote. And for rational functions, we should have maybe none, maybe 1, but definitely not 2 or 3 or 4 horizontal asymptotes. Alright. So, does anybody have an idea how you'd give an answer for a horizontal asymptote?
Y equals
Y equals something. Some number. Just y equals some number because this is a horizontal line. Alright. So, how do I find my horizontal asymptote? How do I find the horizontal asymptote? Anybody have a clue? Think about everything we've done so far. Alright, I'm going to help you out here.
keep the
So-
numerator to 0.
Well, say it again to me.
Set the numerator to 0.
Numerator equal to 0 was already something we did. What was that?
Oh, x-intercept.
Those are x-intercepts. Denominator equals 0.
So
That's
then,
vertical asymptotes. Okay. This one's going to be a little tricky for you. It's not going to be something that's so fast and simple to play around with. But so if I want a horizontal asymptote, I actually really need to compare the degree of the numerator to the degree of the denominator in my rational function. This is probably where you're going to have the most writing, as far as your notes go, but it's gonna be the easiest thing to do. It's right up there with finding a y-intercept, it's super simple to do, okay? So I'm gonna have my function here is my numerator polynomial divided by my denominator polynomial. And I'm gonna say that n is the degree of the numerator and I'm gonna pick m to match your book, because your book uses the letters n and m as the degree of the denominator. And you guys all know how to find a degree. You took a test on that in chapter 2 already, so 2.2, 2.3, 2.2. So you should be able to find the degree of any numerator or denominator, any polynomial function I give you. If it's given in polynomial form, right, which is expanded form with the highest exponent coming first, so you just gotta grab that highest exponent. If it's given in factored form, you have to imagine if it were multiplied out, what would the highest exponent be? So in order to break this down, I'm gonna give you an example for each one. I'm gonna start over here. Here's my first bullet. It's possible that the n is less than m. And here's an example for that. Okay. F of x equals, it's got to be a polynomial on the numerator and a polynomial on the denominator, where the degree of the numerator is smaller than the degree of the denominator. So I might have like 5x cubed minus 4x squared plus 8x minus 6 or something like that. I just made that up off the top of my head because I'm a beast. Okay. Now the denominator, I want to make it up in such a way that what? Say it again?
The m is greater than n.
So the m is greater than the n.